So we are back here. So we are exploring our service mesh project, and on this video I'm going to start to go through the items here that you're addressing, right? So the first thing, let's start from the beginning. We are gonna start the the Minikube. So first, because I have updated, so you need to install the Minikube is the first thing you need, and then you need to start Minikube with a minimum of 4 gigabytes of RAM. So I recommend you, if you have like 16 megabytes of memory, I suggest you put more. So for example, I'm using 8 gigabytes for running my Minikube. So after that, we need to run our basically installing the Kubernetes, the Minikube, right? So for that, we just need to run that. I have already run this command, so nothing has changed. So when you are running that in the first time, I recommend you to run a few times, because some things depend of other things. So for example, in order to have this working, we need to have this already part running and ready to handle what is in the second one. So if you see any warnings or anything like that on the result of this command, I recommend you to just run it again. So then you have our Kelly secret. Then we need to run the fourth, that is to tell to Istio that everything on this namespace default should be injecting this to sidecar. Then we have our application. This is the application using only Kubernetes. So everything that you see here is Kubernetes thing. So it's the deployment, different deployments. Then you see here some servers down. Or is the servers? So you see still deployment, and down here you have the services. Starts to have different services, right? So this is only Kubernetes thing. So Istio will start from the sixth example. So, and basically what I'm doing here is telling, this is the Istio gateway configuration, right? This is for your gateway, and what is worth to mention here is that you are addressing traffic management on that section. So basically, when you are here, you see in the Kiali that you have two versions of our application, right? And this version keep coming up randomically. Like for example, we are here the version 1. Oh, look, you see there is no red anymore. That means that went for the second version. So the experimental one is the red on the top, and the black on the top is the original one. So how we are managing the traffic management is through this virtual service. So the virtual service, it's an entity from Istio that kind of wrap up the Kubernetes service. And here you see that you have said that 50% of the traffic would be going to the original subset, and 50% will be to the experimental subset. And down here, there is more things that is necessary for this thing, but you can come to this file and tweak for your own need, right? So here you just saw how to handle traffic management in kind of way that you can apply A/B test or something like that. So it's important to know that you are using here kind of weights, but you could use as well headers. So you could say if there is a header experimental, we would go to the experimental version. If there is a header for let's say original, would go to the original. So kind of logging on logging. So you can use headers to apply your rules. So you're going to see something using a header in another example here. So I think this is pretty clear, right? That you have two versions, and a very simple way you can manage the traffic with no change in the code, right? So let's go to the next one. Next one will be external service. So basically this one here already have run it again, but then what happened here is you can see that we have here an external service, and this item here is saying that our application is calling this external service, and some calls have been failed because I had introduced a kind of random error there. So some calls will be failing when calling this service. So let's look at how we have done that. So basically, the first thing that you need to do is our application doesn't have to know the external URL, right? So our application would be calling flatmain driver monitoring external. So that's the URL that our application will be calling. So, and from outside we can manage the real address for this service. So we can change this easily without having to touch the application. The second thing that we are doing here, we are saying that every call to this guy here will be accepting calls on the port 80 and the port 43. And down here, very interesting, this part is that any call to this URL, again outside of our application, will be, if is going to the port 80, we are going to be routing to the port 443, because this guy here that we have outside of our cluster will be requiring HTTPS access. So you see that we don't need our application to handle those kind of things. We just call the fixed URL, and here on the service mesh side, in the networking part of our system, we handle this kind of thing. For example, we can do many things, but here we are, for example, changing the port, and we are using a simple TLS certification to be able to call this external guy here. So this is just an example to show how powerful is this service, virtual service. Then you can intercept the calls and apply few rules on that. So in this case, we are doing routing based on an external call. We are making that service be part of our monitoring. So you can see here that it's appearing here. So for example, now before was 100% failing, but now we have 50% it's failing. So we are here on our mesh. Let's say you have this on a screen on your company, and you can see the whole mesh, including external calls. Right? It's very interesting and it's very powerful, this thing. So another thing is they are going to be exploring. It's enforcing TLS, right? So MTLS means mutual TLS. So basically, every microservice in our mesh you'll be talking using HTTPS if you are using REST. But let's say we are encrypting every call here, and to do that, we need first go to our dashboard using Grafana, where we can see, for example, let's choose greater, not really all here. Oh yeah, now it's appearing all. So let's choose this one here, and you can see that the incoming request is not showing anything that would help us to identify that it's a secure connection, right? Because it is not actually. So now we're gonna go and enable our mesh to talk over the encrypted connection, and later, so we can see here very easy how we will do that. So very few lines, we already have the encrypted connection between our microservices. And here you can see that we are using a certificate managed by Istio, but we could use our as well if you decide to. Let's go back to our Grafana and see if already started to show incoming with showing that it's encrypted. So we will need to wait a bit more. So this takes some time to show things on the board. Well, look, now we can see that our request is using this locker and MTLS. That means that our connection is being encrypted now, right? It's very powerful and very simple to use those things. Next is our circuit breaker, right? So to explore the circuit breaker, I will need to go back to our project, and we can see that I have here checking circuit breaker. So what we are going to do here, something that we have skipped that I think we should go back is when I run that thing here on the beginning, we need to wait until the whole Istio services be available, and you can look at those services with this command. So just going back, so you can see that everything is running or it's completed, right? When everything is ready, you then run the rest of the things in order to see everything in place, right? So here we are enable piece by piece because we wanted to be seeing the things getting action. And another thing that we skipped is that you need to find out what is the URL to access our system. So let's go back a bit, and we go and execute this. Then we execute next thing, and then execute next, and then we show the result, what is our gateway. And then we see that our gateway is this. We copy this and we come here, and you will see that it's the same. So it's how we access our application, right? So after that have done, we need having this gateway variable available for our next test, that is this guy here. So this, when you run this, we will see that we will be, basically what we're doing here, you are reaching a URL in our system, and you can see that we are getting some errors from this URL, and those errors, it's coming from our risky service. So when we come to this guy here, there we have something that half of the calls will be failing, and we can visualize those here, right? And what we are going to do is open a circuit breaker if this error happens 3 times consecutive errors in the interval of 10 seconds. So let's see if it works. So basically, keep the eyes here. I'm going to open a new terminal and run kube, apply, -F, and it will be the 9, right? So we apply that. We keep looking here at the error. So yeah, one failed once and failed twice, and then open the circuit. So we are not going to that failed circuit anymore. That circuit was open and is not being reached anymore. So it's fantastic, no? So no, without any code change, we have here a very fault tolerant system. Next one that we're going to be exploring. So you see, it's very simple, very small change. You can achieve those very powerful feature. And let's further see how we add fault injection in our application. So basically, if you want to start to introduce some errors in order to test our system, how we can do that. So first, I'm going to show you what we're adding here in place. Basically, we're saying that for this host, so basically our vehicle telemetry microservice, we want to start to abort 60% of the calls to this guy, right? And this will show. Let's see, wait. Let's enable it. It's fault injection. For this, then we apply that. Now 60% of our calls will be failing, and to see those, we gonna see here that before we were getting speed of our vehicle every time, but since we enable the fault injection, we are gonna see that 60% of the time this is gonna be coming empty. Let's see if you see. I'm gonna come back here, and you'll be looking at the. You see, it's failing. 60% it should be, so it looks like it's more. Let's see if another one comes. Another vehicle. While waiting here, I'm going to show something else that I also have added here as a fault injection. I'm saying that if I have this header, I want to start to slow down all calls to this microservice. So there is this service here. If we have this header in place with this value, we want to delay 100% of the calls in 10 seconds. And basically what that means, it's we need to enable our header. You see, I have a header called xMyHeader, and I'm setting as a dark test. And when I enable that, you're gonna see that it's gonna be slow to load this this image. We can be waiting to that to happen, but then you can start keep moving. And the other test that I want to show you guys, it's how we apply load balancing. And here you see now the image is loaded, so it took 10 seconds to load. It's slow because our delay that we added here. So to show now load balancing, I need to run this guy here. Let's say come back here and go, and right, you can see that we are changing. So basically what we have on this test is this guy here. We have two instances of greater server, and this is happening a load balancing. The default one you see, that is this host name. So basically host name is the pod that is responding to that request, and as you can see that it's switching between we find the end HV and LQ, right? This is a round robin load balance, and this is done by Istio with the sidecar, but this by default it's having this round robin on the load balance, but we can apply different load balancing policies. So for example, I'm going to be applying this list con in order that we can see the difference between both. This one is 11. Then here you can see now that it's kind of keeping HV up, then changing to LK, LK keeping LK, LK, and HV, LQ, LQ, and HV. You could see that the behavior has changed. So because we have this load balance policy in place. So again, very easy to apply load balance. And something that we also can do is to log our requests on top of what we already have. So we have lots of telemetry already in place, but you can decide to having your as well own information. So for example, here you can see that I'm getting some data that is coming from the proxies, the sidecar proxies, and you can see the list of attributes that's available to log, and then I'm kind of generating some variable here, and I'm logging to the console on the mixer pod. So and then we can see the result of it from it using this command here. So I need to change. Show what's happening. Okay, I need to first apply log entry, start a new log entry, and now we check that we are logging what I chose to be logging, right? Right. So also in a cross concern way, you can start to logging things. Another thing that I want to show to finalize is to show how you can apply authentication to a service without touching your code. So basically, we are here able to access our application without any authentication, and then we decide that now we want to be authenticating. So we apply the authentication. You can see here how it's done. It's very simple, and I'm using a kind of static GWT. So basically this will be using GWT to authenticate, and let's see. See, we cannot access anymore, so we need authentication. So now in order to access our system, our application, we need to pass the header with the authentication and our GWT token. Let's see, and there we go, the system is back. So that's the end of our walkthrough. So I think we talked about a few things that you can do with Istio in a very easy way. So this is attempting to transfer the responsibility of some, let's say, things that we could do on the networking side, transferred from the application to the network, and where you can address the challenge and the issues in a kind of cross-concern way, where basically with Istio we are able to programming our microservice. Let's say from here we are able to program how the microservice is going to be behaving, and so applying different things that we saw here. And I think that's all. So we can do more things. For example, we could add retry, we could do times out, we could also add thread pool, connection pool, and much more. So I really recommend you to check out the possibility with Istio in the docs and try out the system. And I hope it can help you in the next microservices system. Thank you very much.